Hello guys, how are you all? All good? Good evening to all of you. So welcome to the live session of Vedantu, and I hope all of you are excited to study this new topic, that is circles. Yes? Okay. Guys, let me tell you, this is a very important topic, rather a chapter, and this is going to help you a long way, right? So whenever you go to class 10, also in class 11, 12, this is going to help you, even in your IIT JEEs also. So make sure you get your concepts and basics clear right now, okay? So, and I hope I'll be able to, deliver these concepts to you properly, okay? So with this, let's see what we need to do today. So this is basically for class 9 CBSE, okay? So what we are doing is, first of all, we will understand what are the basic terms in circles, okay? And then what are the important theorems that you need to understand. So in class 9, if you see, the theorems will be basically related to chords, okay? When you go to class 10, you will get mostly theorems which are related to tangents, okay? So in this class, we will concentrate on chords, and also we will solve problems after we go through the theorems, okay? So stick with me guys, hope you get to learn here. Okay, so let us go through the terms here. What are the terms? For example, say first thing that you, whenever you see a circle or you try to define a circle, so what is a circle, right? So whenever we think about that, we think that there is a center somewhere and there is a line which is equidistant from the point, or which we know as center. Say this O is the center, and I have a line, basically not a straight line, this is a curve, and all the points in this curve, all of them will be equidistant. That means now the distance from this circle to this point, which is known as center, is known as radius. So this is the radius, okay? These are the radius, and these are all equal. So you draw any straight line from the center to this circle, you will get the radius which is of same length, okay? So this is center, radius. Now circumference. Now what happens is, if you see this circle, okay, this outside length is also known as circumference. We can also calculate what is the length of this. We will see that later. And arc. What is arc? Arc means any part of this circumference. Okay. So for example, let us say this. This is an arc. If you see here. Okay, this black one. Okay, this black one is the arc. This one. So now let me mark this. Say this is A and this is B. So you see this AB is the arc. But then there is one more arc from A to B, that is on this side. Now if you see, this arc is bigger than this smaller one. So basically we call this one as minor arc and this one as major arc. Okay? Fine. And you see sector is also created. So what is sector? Sector means, if you see here, you will get area from this arc to the center. And here also I will have this area. Okay. So I have two areas. So this is known as sector 1 or minor sector, and this is the major sector. So basically these names are given so that we don't confuse when they say that this arc subtends an angle. So what is the confusion can be created? What are the types of confusions? Confusion is, suppose I tell you I have a circle and I have a arc AB. Okay, and I tell you that I have a center O and at this center O, this arc subtends an angle AOB. Now, which angle am I talking about? Right, so I have one angle here, that is also AOB, and this is also AOB. Right, this is the reflex one, as we can see here right now. But then, how will we understand? So we talk in terms of arc, or we talk in terms of sector, right? So basically this is the minor, this part is a minor arc, and if we are talking about this greater part of the circumference, we say this is the major arc. Okay, so that's all. So we don't get confused which we are talking about. And similarly, the sector by this minor is the minor sector, and this will be the major sector. So let's go back. Okay, now very important, that is secant. What is secant? So let us see what is secant. So suppose we have a circle, okay, and now I take a line, straight line, and the straight line cuts the circle at any 2 points. See here, I can take the line at anywhere. All of these are secants. That means secant is when a line cuts a circle in 2 points, at 2 points. So at this point and this point, right? So these are all secants. And what is chord? So the next thing that we will see is chord. So what is chord? Chord is the part of the secant which is, inside this circle. So say AB, so this line segment of the secant is known as chord. Okay, so basically if I say chord, you will be understanding something like I have a straight line which joins any 2 points in a circle. So I will start from here, I can go here, 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 anywhere. So I just have to, both the ends should be on the circle, that's it. Okay, so this is a chord. It can go anywhere. What else? Now we have diameter. So if you know guys, diameter is nothing but also a chord, but that is the longest chord. Okay, so this is also a chord, diameter is also a chord, but that is the longest chord. And always we need to understand and remember that the longest chord or the diameter will always pass through the center of the circle. Okay, and this chord divides this circle in 2 segments, segment 1 and segment 2, and both the segments should be equal, right? And this was the first known proof which was given by Thales. If you have studied Euclid's geometry, you'll be getting there. Now see, if we have a chord, then also it divides the circle in 2 segments, right? Now suppose I have a chord, and this chord divides the circle in 2 segments. So they say this is segment 1 and this is segment 2. And if you see, this is the bigger segment. Okay, and this is the smaller segment. Okay, but if I have a diameter, okay, if I take a diameter, it divides both the segments in equal parts. That means both of them will be equally divided. So here, if I have any other chord other than diameter, then there will be one will be more and the other segment will be less. So one will be major, other will be minor. So that are the basic concepts. Segments is done. And lastly, most important thing to understand is tangents. So tangent means, suppose I am talking about this chord, and this, what is secant? Secant means which cuts the circle at 2 points. But tangent means when it comes out and it touches the circle at any 1 point. So now this is a tangent. So if you want to visualize, you can think about like there will be cars and the cars will have the tires, or bike will be having tires. And when suppose the bike or the car is running on the road, okay, so suppose this is bike or cycle, whatever, right? So these are the wheels. So what happens? The wheel runs on the road, and the road is always, it seems like it is in tangent with the wheel. Okay, so that means that is how you can visualize in your day-to-day life of circle and tangents. Okay, so this let us say this is like a wheel, and this is rotating in this way, and this is my road. This is my road, right? So this particular line is known as tangent. And there are few properties of tangent. For now, you just need to know that if I draw a radius at this point, right? If I try to draw a radius at this point, this will be 90 degrees. This is a most, or this I can say this is a fundamental, property of a tangent, that if I draw a line from this radius, from the center to the point where I have drawn the tangent, then I will have 90 degrees. Okay, not at any other point, not at this point. I have to draw this radius at this particular point where I have the tangent. Okay. Similarly, you see a circle can have infinite numbers of tangent. Okay. But at one point I will have one and only one tangent. Okay. I can have lots of tangents. I can have infinite tangents. But at one point I'll have only one tangent. Okay. This is very important. So let's move on. So these are all tangents. So hope you got it. Yeah. Do you have any doubt? Okay, cool. So now what we will do is, let us focus on the theorems which are related to chords. And this is where most of the numericals will come from. Okay. So the first theorem that you need to understand is the equal chords. Okay, suppose you have two equal chords. Okay, it subtends an angle or equal angle at the center. Now when I say this, you need to understand what does this means, that is, what does subtend means. Now if it bothers you, let me just explain, let me take just a few minutes to explain this. So suppose what happens is, I have a chord, let us say this AB is a chord. Okay, this AB is a chord. Now this AB can subtend an angle at any point, right? For example, say P is a point and it will subtend. That means now I will draw a line up to P from these 2 points of the chords. So it will subtend an angle APB. Similarly, this chord will subtend an angle AOB on the center. Similarly, it will subtend an angle AQB on the other side of the segment, right? So this is what is known as subtended, angle subtended by a chord. Okay, now you see one important thing which you need to understand here is, suppose whenever I have a chord, it can subtend two angles, okay, on the circle. For example, it can subtend one angle on this side of the segment. See, there are two segments, segment 1 and segment 2, right? It can subtend one angle on this segment, and it can subtend one more angle on this side. Okay, of course it can subtend many angles on this side, but basically this is one part of the segment and this is the other part of the segment. So basically this is a major segment, this is the minor segment. Now let us try to understand the first theorem, which says equal chords of a circle subtends equal angle at the center. That means there are two chords, say there are two chords AB and CD. So you see there are two chords and it is said that AB and CD are chords, okay, and both of them are equal. Okay, AB is equal to CD. So if AB is equal to CD, then they're saying that they subtend equal angle. That means we need to show that this angle COD is equal to AOB. How do we show that? Okay, so you see in these two triangles, so what we will do is, first of all, we will join this point C with the center, D with the center, A with the center, B with the center. We'll join this, and once we join this, we can say that these two are equal and also these two are equal, that means what I'm saying is OA is equal to OB is equal to OC is equal to OD, because these are all radius of a circle. So now you see in the between these two triangles OCD and OAB, I can apply congruency, that is side, side, side. So this side is basically equal to this side, and this side is equal to this side and also equal to this side. So by side, 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 I can say that these two triangles are congruent. So if these two triangles are congruent, then I can say that this angle AOB is equal to angle COD. So in this way, I can prove this, that if I have two equal chords, it can lie anywhere in the circle, but it will subtend equal angles at the center. This is very, very useful. And the reverse is also true, or in other words, converse of this is also true. That means if two chords subtends equal angle at the center, then both the chords are equal in length. We can prove that also in the similar way. Okay. So I hope there is no doubt in this one. So let me go to the next one. The next theorem related to chords is, suppose I have a chord AB and it says angle subtended by a chord on the center is twice the angle subtended by the chord at any point on the circumference. So I take any point on the circumference. Let us say P is a point on the circumference, right? And I draw, or I find out this is the angle which is subtended by this chord on this point. And this is the angle which is subtended by this chord on the center. So they are saying that AOB is twice of APB, right? Now someone might think, what if I take P here? What if I take P here? Will it be same? So let me tell you guys, we should not take P here. So this particular theorem is true only when you take this P on the side of the segment. Suppose this chord will divide this circle into two segments, right? This is say bigger segment and this is the minor segment. Now you see center is on this side of the segment. So we have to take the point on the same side of the center. Okay. So now we can take P at any point. Now you might think, what if I take P at any other point? Okay, you can take P at any other point also. So say this also can be my P. So I will, if this is my P, then also this relation will be true. So now let us prove it. Okay, so how to prove it, you see. Okay, let me just remove these P's. Let me take any one point. Let us say this is my point. Now how do I prove this? So first of all, what I will do is I will connect this point P and O. Now once I connect this P and O, now I will name these angles. Okay, so I'll name these angles to save my time. So let me say this is angle A. Okay, and let me see how I have named it here. Yeah, and let me say this is B and this is C. So I have named angle AOB as A, angle BOP as angle C, and angle AOP as angle B. So these are the names that I have given. Also I will take few more names. Let me say this two angles. What is the relationship between these two angles? Now if you see triangle OAB, this side is equal to this side, right? So this is an isosceles triangle. So if this is an isosceles triangle, that means this angle is equal to this angle. Similarly, in this triangle OPB, this side is equal to this side. So definitely this angle should be equal to this angle, right? Similarly, this angle should be equal to this angle. So let us name these angles also. So what we can do is we can name this as Y and this also as Y. Let us say this is X and this angle is also X, and this angle as W and this angle as W. Now we can start relating them. Now if you see triangle AOB, that is AOB or OAB, what happens is this angle A, okay, see here, this angle A plus this angle Y plus this angle Y is 180 degree. Okay, so we know this particular thing. So from here we can say that A is equal to 180 minus 2Y. Okay, so this is one relationship. Similarly, in this way I can find out the relationship of others also. So B can be written as 180 minus 2x. Similarly, C can be written as 180 minus 2W. Right? So we can write these angles now. You see this ABC, okay, this forms a complete one circle or you know, complete angle here. I will get a complete angle here. So which is 360 degree. So I can write that A plus B plus C is a complete angle, that is 360 degree. So therefore A is equal to 360 minus B minus C. Now we have seen that B is nothing but 180 minus 2x and C is nothing but 180 minus 2W. So I just put the values here. In whatever B value I just put it here and C value I put it here. So I've written 360 minus of this thing and minus of this thing. So in this way I will get 360 will be get cancelled by this 180 and 180, and what will be left is A is equal to 2x plus 2W, or in other words 2 times of x plus W, right? And what is x plus W, guys? X is this angle and W is this angle. So I can say that this x plus W is nothing but angle APB. So from there I can prove that angle AOB, that is this angle, is twice of this angle. Okay, so this is very, very important. So hope you get it, right? Okay, so guys, the next theorem, okay, is it says the angles in the same segment of a circle are equal, and that is obvious, right? Now I have just told that I can take this point P at anywhere, right? I can draw this point P at anywhere. Now from this segment, suppose I draw this angle. So all these angles will be equal because I can prove all of them in this way. So the proof here is very simple. What we will do? We'll take a circle, right? And we have this, suppose we have this chord. Now I just take a point P here and I draw this in this way. Okay, so now I say that this angle is half of the angle subtended at the center. Similarly, I take somewhere else and I say that again this angle is half of this, so therefore this angle should be equal to this angle. In this way, any point on this part of the segment, okay, on this part of the segment, any point I draw a, or I subtend any angle from this particular chord, the angles will be equal. So now you might think, what about the other half of the segment? You might think this, right? So let us also see that. So what happens is, suppose now I draw somewhere, I just take any point P and I draw an angle, right? So okay, so what I'm saying is basically that these two angles are equal. You draw this anywhere, okay, this angle will be equal to this angle. Now I can draw an angle here, 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 these all will be equal. Now what if I draw it here on this part of the segment? So if I draw anything on this part of the segment, there is a relationship which we can find out. We'll slowly see. So this is known as, now if you see this point A, B and say this is P and this is Q. So if you see A, B, B, Q, this is nothing but a quadrilateral, right? And all the points of this quadrilateral are on the circle. So these types of quadrilateral are also known as concyclic quadrilateral, and there is a theorem and some relationships on this. We will come to that after some times. But see here, this angle will not be equal to this angle. Okay, So this particular theorem, whatever they are saying, angles in the same segment, okay, this is very important, of a circle are equal on the different segments. Now these are angles on the different segment from the chord. So these two will not be equal, but there will be a relation between these two. So we'll come to that after some time. Next thing. Next theorem, that is angle subtended by a diameter on the circumference is a right angle. That means if I have a diameter, suppose AB is the diameter, okay. Now it subtends an angle and they're saying that this is 90 degree. Now this is very simple. Why? Because I know that this angle is 180 and I know that angle subtended by a chord is half of the angle subtended by the chord on the center, and if this is 180 degree, so this will be half of 180, that is 90 degree. Now important thing for us to visualize that this can be anywhere. I can subtend this angle 90 at any side of the segment and any part. Why any side? Because now it divides the circle into two equal halves. So now it will be, see, any angle subtended by the diameter at any part or any point of the circle should be 90. Must. Okay, very important theorem. Next, if a line segment joining 2 points, okay, now suppose I have a line segment, say A and B, and this line segment joining these 2 points subtends equal angles. Say this angle is equal to this angle. So this is also A and this is also angle A. And say this point is P and this point is Q. So what they are basically trying to say is that all these points P, Q, A, B will lie on the same circle or they will be concyclic. Concyclic means these points A, P, Q, B will lie on the same circle. Okay. Now you see what they are saying is, let me read it again. If a line segment joining 2 points, so this is a line segment joining 2 points A and B, subtends equal angle at 2 other points. So they are subtending equal angles at P and at Q, lying on the same side of the line. So both P and Q are above this line. So I cannot take P and Q on the opposite sides of this line. So both of them are on the same side of the line, right? Once I do this, then I can say that A, P, B and Q are concyclic. Okay. So now let me try to do this. Let me try to see if I get this as concyclic or not. So that means if I draw a circle with some radius, all these points will lie. See, this is what is known as concyclic. So now if I draw a circle, okay, then there will be one circle which will have all these 4 points lying on it. Okay, so this is the theorem. And basically this is the converse of the theorem which we have just seen. So we have seen this theorem, right? That in a circle, if I have a segment, they subtend equal angle, right? So if they subtend equal angle, these points should lie in the circle. So this is nothing, basically the converse of that particular theorem. Okay. After that, next very important segment is what we are talking about, this quadrilateral. So we get a quadrilateral, or if we draw, angles on different side of the segment. Suppose this is a chord and I have drawn angle at, I have taken 2 points on 2 different segments of this chord, and now I have subtended the angle. Now you can see this is a quadrilateral, and this type of quadrilateral is known as cyclic quadrilateral. Okay, cyclic quadrilateral. And the property of this cyclic quadrilateral is the sum of this angle and this angle will be 180. Similarly, the sum of this angle and this angle will be 180. So basically what I'm saying, that if I have 4 points if I have 4 points and I try to draw, okay, I have 4 points anywhere, okay, in the circle. Say this is A, B, C, D, and I try to draw a quadrilateral here. This is known as cyclic quadrilateral, and the property is this angle plus this angle will be 180, and this angle is 180. So what is the theorem? So the opposite sum of the opposite sides of a cyclic quadrilateral will be 180 degree. Okay, and the converse is also true. That means if I have a quadrilateral, okay, converse is important. If I have a quadrilateral and the sum of the opposite sides is 180, then all the 4 points of the quadrilateral or all the 4 vertices of the quadrilateral are concyclic, right? That means they lie on the same circle. Okay, so this is also very, very important, and there are a lot of applications of this. Let us go to the next one. Now, what about distance from the origin or the center to the circle? Now, if you see, this is the center and I have a chord, say AB. So they're saying the perpendicular from the center of a circle to a chord bisects the chord. Now, if you know the perpendicular from the center, so basically we are trying to find out the distance from the center. So if I have a circle and if I take a chord here, I can take a chord in any direction, anywhere. Okay, say this is a chord, and now let me say this somewhere here is the center. Okay, now if I take the distance of the center and this line, that will be basically the perpendicular line, right? So this is the distance. So this is perpendicular, 90 degree. Let me say this is A and this is B, and this center is C or O. Let me take, and let me say this point is M, as I have named it here. Now they are saying that this perpendicular from this origin or center to this line will bisect this. That means I need to show that AM is equal to MB. Now this is also very, very important to show. How will you show this? This is very simple. We just draw or connect these two. So we form a triangle. If you see here, so this side is equal to this side. This is 90, this is 90, and this is the common side. So from right angle hypotenuse side theorem, we can prove that these two triangles are congruent. Once we can prove that these two triangles are congruent, we can say that AM is equal to MB. So we can easily prove this with the help of RHS. Okay, so now next one. Next theorem is equal chords of a circle are equidistant from the center. Right? So what am I saying? Equal chords of a circle. So if I have two equal chords, they are equidistant from the center. Equidistant from the center means if I draw a perpendicular to the line or to the chord from the center, this length OX and this length OY will be equal. Let me draw it once more so that you get the clarity. So what I'm saying is, suppose we have two chords. Let me take two chords. So let me say this is one chord. Okay. And let me take one more chord here. I can take the chord in any direction. So let me take, these are two chords. Okay. And this is A, B, and this is C, D. And I know that AB is equal to CD. This is given to me. This is given. So now I need to show that if I have a center somewhere here, and if I draw a perpendicular on this, okay, I can move the position of this also so that you don't get a straight line here. Okay. So now it doesn't matter what is the alignment of the chord. That's why I have moved the chord to show you. So alignment of the chord can be anywhere. So this is AB. Okay. Now say this is the center and I have drawn two perpendicular. So this is X and Y. So basically OX is perpendicular to AB and OY is perpendicular to DC. So now what they are saying is, if AB is equal to CD, then OX is equal to OY. This is, we need to show this. How do we show it? Now guys, see, this is perpendicular, right? So if this is perpendicular, we know that. So how do we show? Let me just prove it here. So we know that AX is equal to XB, right? And so that means this is half, right? And this AB is equal to CD. So this should be equal to CY is equal to YD. So this half is equal to this half is equal to this half is equal to this half. So these all parts are equal, right? Now let me try to draw a triangle here. So I draw these two triangles. And I have, this is 90 and this is 90. Now you see in these two triangles, this is the radius, this is the radius. So OB is equal to OD, as both of them are radius. And this XB part is equal to YD. We have just shown it here. And this is 90 degree. Again, from right angle hypotenuse side, we can say these two triangles are congruent. So I can say that from this I can say OX is equal to OY. Simple, right? So I can say that equal chords of a circle are equidistant from the center. Very important. So guys, that's all from the most important theorems that you will be needing in class 9 to solve approximately all the questions that you will get, right? So now let us also go through few of the numericals. So first question to you is this. Okay, let me see how many of you can answer me. ABC is a triangle. Okay, so ABC is some triangle and ADF is some triangle. Okay, and they are saying that point A, D, E, C are lying on the circle. That means these are concyclic. Okay, so now they are saying is ADF is 105. So this particular angle, this angle is 105, and AFD, that means this angle is 30 degree. So they're saying find out ABC. So you need to find out this angle. How will you find it? Solve it, guys. Give me the answer. All of you. Okay. Done. So see guys. Okay, I'm getting few answers. So let me give some hint to those who are not solving it. See here guys. See this triangle ADF. If you see the triangle ADF, you know this angle, you know this angle, so you can find out this angle, right? So you see angle A here plus angle D here plus angle F here is 180. So from here you can find that angle A is equal to 180 minus 105 minus 30, right? So what will you get here? You'll get 45 degree. So this angle you got as 45. Now what? Now how will you find it? Now you need to find this angle. So which property we will use? We will use the property of cyclic quadrilateral, right? So see guys, ADEC is a cyclic quadrilateral. Have you seen this? So that means if sum of angle D and angle C will be 180 degree, right? So if this is 105, this will be 180 minus 105, that is 75, right? So we got, now you come to this triangle ABC. So in this triangle ABC, if this is 75, if this is 45, what will be this? 180 minus these two, right? So if I do 180 minus these two, I will get angle 60. So B is the right answer. So see here, I will just quickly go through it again. So in triangle ADF, this is 30, this is 105. So you will get this as 45 degree. And this ADEF is concyclic. So if this is 105, this will be 75. Now in triangle ABC, if this is 45, this is 75, you will easily get this angle as 60 degree, right? So this is how you can solve this. Okay, let us go to the next problem. So in this question it says, I have a chord and I have a triangle ABC which is inscribed inside this circle such that AB is equal to AC, okay? And there is one more triangle BDC and there is one more triangle BEC. So see the figure here. So in this figure it is given that AB is equal to AC, okay? And this angle is given as 100 degree and this angle is X. That means what is X? So X is nothing but angle ACB is called as X. And what is Y? Angle BDC is called as Y. So they are asking find X and Y. Do it guys. Yeah. So again you can use the cyclic property, cyclic quadrilateral property. Yes? Yeah. So using that we can say that, see, BDCE. This is cyclic quadrilateral BDCE. So if this is 100, so this will be 80 because sum of these two will be 180. So directly I got that Y will be 80. Yes or no? Okay. Now if Y is 80, this is also 80 because this is also a cyclic quadrilateral. Or in other words, from an equal segment, the angle that is subtended on the same side of the circle gives me equal angle. So if this is Y, this also becomes same angle Y, right? So that means this is also 80 degree. So now you need to find out this angle X. Now if you see triangle ABC, now ABC is an isosceles triangle. It is isosceles. It is given in the question that AB is equal to AC. So that means if this is angle X, this will also be angle X. So we know that in a triangle Y plus X is equal to 180 degree. So from here 2X is equal to 180 minus Y and Y is 80. So 2X is equal to 100. So X will be 100 by 2, that is 50. So answer will be option, no, not option A. X is 50, Y is 80. So option C, right? Yeah. So X is 50, Y is, this is the right answer. Okay, fine. Let us go to the next question guys. Third one is, you have again a triangle ABC and this chord BC is subtending an angle A at this point of the circle and on the center it is subtending an angle BOC. And they're saying this is angle A and this is angle B. That means OBC is angle B. So find out the sum of these two angles. So A is angle BAC and B is nothing but angle OBC. So now you need to find the summation of these two. How will you find it? Let me see how many of you can answer. Come on guys. Yeah. Okay, let me give you one hint. So what is OBC guys? OBC. See this triangle carefully. See, this side is equal to this side, right? So this angle will be equal to this angle. So if this is B, this is also B. And what is the relation between this angle and this angle? So if this is A, we know that we have just learned from the theorem that the relationship between these two is twice, right? So this will be twice A, and this is also B. So now you got it, right? So now in this triangle, this is twice A. So twice A plus B is equal to 180 degree, right? And twice A plus twice B is equal to 180. So from here A plus B is equal to 90 degree, right? So A plus B is 90. So option B is the right. Okay, fine. Let me go to the next question. So next question says AB is the diameter, okay, of a circle with center O. And then I have a triangle, say ADB, and I have one more triangle ACD. So this angle is given as 75 and this angle as 35. Okay, so they are saying find out angle BDC. BDC means I need to find out this complete angle. Okay, solve it guys. Yeah, all of you. Okay. Don't guess guys. Try to solve it. So which theorem will you use here? Which one? So any theorem which you have learned? Any theorem which you have learned with respect to diameter? So if you go back and if you remember that the diameter subtends 90 degree on the circumference on any side, any segment. So that means we got one of our angle. So this AB is the diameter and you see this is 90 degree. So if this is 90 degree, this is 75. What will be this angle? You'll get this angle. Now you solve it. Solve it. Come on, give me the answer. All of you. I want the answer from all of you. Okay. So let me just say that in triangle ADB, angle ADB is 90 and this angle DBA is given as 75. So what should be this angle? So therefore angle DAB will be 180 minus 90 minus 75. So 180 minus 90 is 90 and 90 minus 75 is 15 degree. So I got this as 15 degree. Now what to do? Yeah, now it's very simple guys. See again, you can use this that A, C, D, B are concyclic or I can say that this is a cyclic quadrilateral. So if this is a cyclic quadrilateral, then this complete angle and this complete or sum of this complete angle should be 180 degree, right? So therefore I can say angle BDC plus angle CAB should be equal to 180 degree. And what are they asking? They are asking me BDC, right? So therefore angle BDC will be equal to 180 minus angle CAB. And what is angle CAB? CAB is nothing but 35 plus 15, that is 50 degree. So I'll give this as 50 degree, not 150. So this is 50 degree. Now if I subtract this, I will get 130. Yeah, few of you have given me the right answer. So that is option B, which is 130 degree. Got it, guys? Okay, very good. So let me go to the next question. So solve this, and guys, if you have any doubt, further doubt, and if you want to clarify anything, you can mail me. And this is my mail ID, mridul.ghosh@vedantu.com. Okay, so you can mail me your doubts on this particular mail ID. Okay, solve this question. Solve it, guys. So AOB is given as 100, DAC is given as 30. You need to find out APB. APB means you need to find out this blue one, this angle. But you see, you cannot apply the theorem that we have learned that this is half of this, because this point is not on the circle. Okay, so be very, very careful to this. Okay, so you have to apply this. For example, you can say that this angle is half of this angle. You can say that. So you can say this is 50 and you can say this is 50, because both of them are on the same side and both these points are on the circle. Now how will you solve it? Okay, this is one hint. Then this is simple, right? So we can, yeah, so this angle we can find out in triangle. If you see in triangle APD, what is this angle? Angle APD is equal to 180 minus 50 minus 30, yes or no? See here in this triangle. So what is this angle? So it will be 50, 30, 180. So this will be 100 degree, right? So if this is 100, what is this angle, guys? These are vertically opposite angles. So this is also 100. So say this APB is X. So if this is X, this angle is also X, right? And this is a complete angle. So I know that 2 times of X plus 2 times of 100 degree is equal to 360 degree. So I'm explaining again, this is 100 degree, this is 100 degree, and this is X and this is X. So if I add all of them, I should get 360 degree. So from here, twice of X is 360 minus 200, that is 160. So therefore from here I can say X is equal to 80 degree. Simple. Okay. Now one more question. This is very beautiful and important question. Try to solve this. So it is said that I have 2 lines AB and CD, and AB is the diameter. Okay. And it is said that AB is parallel to CD. So these 2 lines are parallel. Okay. Now they are saying that they have drawn to one triangle CED such that E is on the circle. Okay. And then they have say that this transversal, okay, so this is the transversal perhaps, and this angle is 25. This is what they have said. So now you need to calculate what is this angle. How will you do it? I'll give 1 minute for you to think about it. Then I'll give you a hint. So basically one thing which we can easily see is if this is 25, then of course this is 25, right? Why? Because these are alternate interior angles, because this line is parallel to this. This we can easily see. Okay, now what? Now we need to find this angle. How will you find this? What will you use? Okay, I'll give you one more hint. That is, you can use this, right? So we know that if I have a chord, okay, then the angle subtended by the chord on the circumference is half of the angle that is subtended at the center. Yeah. So you can use this concept. So this is the hint. So this is say O and this is say E. So this angle, if it is X, this will be twice of X. How will you use this here? Yeah? How will you use it here? Yes, of course you need construction, right? So take the construction. So what you do is join these 2 points. Join this point and join this point. So once you join it, now you see what to do. Now if you can find out this angle, you can find out this angle. How will you find out this angle? Okay. This is the important part. Try to think, try to think. Can you use this particular thing anywhere else? Yeah. Can you see it somewhere else? Can you see that this angle which is subtended by AC? So for example, let us say this is AC. If this is AC and this is say O, okay, let me draw it again. That will be better. So let me draw it and show it to you. See here. Say this is AB, okay, and this is, so say this is a chord AC, this is a chord. Just think in this way. This is a chord. So this is the angle that it subtends here. And where is the center, guys? I have said that this AB is the diameter. So of course center will be somewhere here. So what will be this angle? Yeah, what will be this angle? Don't you think this angle will be twice this angle? So if this is 25, what will be this? This will be 50. Now try to solve it. Yeah, of course. So see, if this is 50, similarly this DB is subtending 25 at point C. See here. So DB will subtend again 50 degree here, right? Now it became very simple, right? Now we know that AOB is a straight line. So this complete angle here is 180 degree, right? So this complete angle is 180. So if this complete angle is 180 and this is 50 and this is 50, so what is the part which is left? So the part which is left should be 180 minus 100, that is 80 degree, right? So I got angle COD is 180, that is because, yeah, this is straight line 180 minus 100. So that is nothing but 80 degree. And if this angle is 80, what is this angle? This angle is 40 degree, right? So from here I can say this is 40 degree. So guys, I hope you liked the class, right? And I hope you have liked the theorems which I have taken and questions which we have done. And now in case if you have any doubt, okay, you can mail it to me. So mail ID is mridul.ghosh@vedantu.com. And guys, there is a course which is designed for you, that is a short-term course, and the course link is this. So please note it down. You can go and enroll for this particular course, that is http://vdnt.in/circle9. Okay, so if you do it, you will go to a page where you can enroll for this particular course. So this is a course which will be covering you the complete syllabus, right, till your final exams. Okay, so go through it and hope you liked it. So see you in my sessions. Take care. Bye bye.